Hi, let us spend some time to talk about the concept of curtailment. What does it mean by curtailment and why it is necessary? And also, how do we deal with the curtailment of reinforcement? First of all, what is curtailment? It involves terminating or reducing the reinforcement bar in a specific locations of a structural element when that specific amount of reinforcing bar is not necessary. The purpose here is to optimize the reinforcement use, leading to saving of the material used, without compromising the structural performance of the member. It means that when we do this terminating and reductions of the reinforcement bar in the member, the strength and the performance of the member is not affected. We only remove the reinforcement at the regions which is not necessary. Not only that, this process of curtailment can simplify the construction process and also to prevent the congestions of the reinforcement bar, especially at the beam to column junctions, in order to maintain the quality of the concrete compaction. Imagine a junctions of the beam and column. You have beams from both directions as well as column. There will be reinforcement from the beams, another set of reinforcement from another beam, and also reinforcement from the columns. This will lead to concentrations of reinforcement at the junction here, limiting the space between the reinforcement that allows concrete to flow through in between and maintain a good bond with the reinforcement. Now, in the design of a reinforced concrete beam, normally you will analyze the bending moment diagram. Based on the bending moment diagram, you will determine where you're going to put your tension reinforcement. And when you design the tension reinforcement, you are designing the tensile resistance against the maximum moment, normally at the midspan and also at the support. However, if you observe the typical bending moment diagram, you will see the moment reducing along this span. That means near to the end support, there will be less moment and less amount of reinforcement bar is required. As for the hogging moment, it is the highest at the internal support. Further away from the internal support, the hogging moment reduces. That means the amount of reinforcement bar required further away from the internal support reduces as well. One way to place your reinforcement is by providing resistance to the maximum moment and then maintain the same amount throughout the span. But you know that there are areas which is not necessary. This gives you rooms to further optimize the usage of the reinforcement, and this is when the curtailment or reinforcement comes in. So this explains what is curtailment, which is a process for you to reduce the amount of reinforcement bar at the regions which is unnecessary. And why do you need to do curtailment? You would like to save the materials, simplify the constructions, and also to prevent congestions of the reinforcement bar so that the concrete can be cast properly. And then when you do the curtailment, you will need to refer to the bending moment diagram. That will reflect to you where you're supposed to put the reinforcement and how much reinforcement is required. At the regions which is unnecessary, the amount of reinforcement may be reduced. By doing this, doing curtailment of the reinforcement will not compromise the integrity and the safety of the structural element. Next, where do we often see curtailments of the reinforcement? Normally we do curtailment in beams and also slabs. There are references guiding you how to do the curtailment based on the simplified approach, which is applicable for the beam and also for the slabs, which differ slightly. However, before we look into the simplified rules of curtailment, we will need to first establish the fundamental principles behind it, which we will discuss in detail in the following videos. For the time being, you just need to remember the basic concept of doing this curtailment. Also, you need to know that the curtailment is not a really precise process, which is inherited from the approximations during the structural analysis. You know, in the calculations of the loading acting on a beam or a slab, we do approximations in terms of the design GK and QK. Also, we are taught the factor of safety 1.35 and 1.5 for GK and QK respectively. And then if we are talking about a continuous span, we do moment distributions method. This involves analyzing the members by assuming different types of load cases and then come up with the envelope bending moment diagram. Due to the reason that the structural analysis is by fundamental and approximations, when you do the curtailment, it cannot be too precise. That's why in the typical simplified rules for the curtailment, they allow for a certain degree of the tolerance, allowing slightly greater resistance than what is required in order to cater for such inaccuracy. And then bear in mind that the outcome of the curtailments may not necessarily be ultimate, as it tends to be influenced by the other serviceability, durability, and detailing requirements. Giving you an example. Let's say now if you have calculated the amount of reinforcement bar required at the internal support here is 2T12. Based on the curtailment rules as illustrated here, you may reduce 40% of the amount of reinforcement bar up to a distance of 0.25 effective length, and then you may reduce further until 20% remaining towards the end support. However, due to the practical considerations, you will require at least 2T12, even though no compression reinforcement is required in the beam. Now in this case, if the internal support requires 2T12 and the minimum required amount of reinforcement bar, it is also 2T12. In this case, there shouldn't be any reductions. Instead, you're going to have 2T12 reinforcement bar applied throughout the span without any curtailment. This is what it means by the curtailments can sometimes be influenced by the other requirements.